Square numbers. In this module, you will learn about the topic square numbers. Look at this square. What is the area of this square? We all know the area of the square is side into side. For example, one side of the square is given as 3 centimeter. Then the other side of the square would also be 3 centimeter. So the area of this square can be calculated by multiplying the number, that is side 3 centimeter into 3 centimeter. So we get 9 centimeter square. Thus, this area number which we got is called the square numbers. Look at this. Here 4 can be expressed as 2 into 2 is equal to 2 square. 9 is expressed as 3 into 3 equal to 3 square. 16 is expressed as 4 into 4 is equal to 4 square. So such numbers which can be expressed as the product of the number with itself, like 1, 4, 9, 16, 25, 36, are known as square numbers. Generally, we can say a natural number c, which can be expressed as b square, where b is also a natural number. Then does it mean that c is a square number? For example, can we say 24 as a square number? As we know that 4 square is equal to 16 and 5 square is equal to 25. So if 24 is a square number, then it must be the square of a natural number between 4 and 5. But there is no natural number between 4 and 5. So we can say that 24 is not a square number. Now let us first find out the square of 1. By multiplying 1 by 1, we get the square of 1 is equal to 1. Similarly, we can get the square of 2 by multiplying 2 into 2. Hence, we get the square of 2 is equal to 4. Likewise, the square of 3 is 9. Now can you say what is the square of 4? Yes, the square of 4 is 16. Similarly, calculate for other numbers too. Thus, numbers 1, 4, 16, and so on are the square numbers. They are also known as the perfect squares. Now let us understand about the properties of the square numbers. Square number always ends with 0, 1, 4, 5, 6 or 9 at its unit place. Look at the table. This is showing the squares of the number. You can see the ending digit of the square number is ending with 0, 1, 4, 5, 6 or 9 at its unit place. None of these ends with 2, 3, 7 or 8 at its unit place. The number of zeros at the end of a perfect square is always even. In other words, a number ending in an odd number of zeros is never a perfect square. For example, 400 is a perfect square, as number of zeros are 2, even, and 4000 is not a perfect square, as the number of zeros are 3, odd. Look at this table. You can see 10 square is 100, 20 square is 400, 80 square is 6400, 300 square is 90,000, 4000 square is 1 crore 60 lakh. All the perfect squares have even zeros. Squares of even numbers are always even numbers, and squares of odd numbers are always odd. For example, 8 square is equal to 8 into 8 equals to 64. Here we can see that both the number 8 and 64 are even numbers. Let us see one more example. 7 square is equal to 7 into 7 equals to 49. Here too, we can see that both the numbers 7 and 49 are odd numbers. If a number has 1 or 9 at its unit place, then its square ends in 1. For example, look at this table. Here we can see that the numbers ending with the digit 1 at its unit place have their square numbers ending in digit 1. If a square number ends in 6, then the number whose square it is will have either 4 or 6 in its unit place. From the table you can see there are examples that a square number ending in 6 have either 4 or 6 in its unit place. Now we will learn some more interesting patterns related to square numbers. One of the patterns is adding triangular numbers. Do you remember about triangular number? Let's revise it once. The triangular numbers are the numbers whose dot patterns are arranged as triangle. Look at this pattern. From this you can see how the triangular numbers are formed by partial sum of the series. That is, 1 plus 2, plus 3, plus 4, plus 5, and so on. Let us try and observe adding two consecutive triangular numbers. You will observe that we get a square number. For example, look at this pattern. Here 1 plus 3 is equal to 4. That is square of 2. Similarly, 3 plus 6 is equal to 9. That is 3 square, and so on. From this we can conclude that the sum of the two consecutive triangular numbers gives us a square number. Now let us understand another pattern which shows the numbers between square numbers. Look at this figure. You can see that between 1 square and 2 square, there are two non-square numbers. That is, 2 and 3. Which is one less than the square number? Further, between 2 square and 3 square, there are 4 non-square numbers. That is 5, 6, 7, and 8. Let us understand how this non-square number comes in between square number. Let us say we have two consecutive numbers, that is n and n plus 1. Second, their square are n square and n plus 1 square. So, the difference between them is n plus 1 whole square minus n square, which gives us n square plus 2n plus 1 minus n square, which is equal to 2n plus 1. We find that between n square and n plus 1 square, there are two n numbers, which is one less than the difference of two squares. Thus, in general, we can say that there are two n non-perfect square numbers between the squares of the numbers n and n plus 1. Now let us understand the other pattern of square number by adding odd numbers. In this you will learn how by adding odd numbers we get a perfect square. Look at this. You can see 1 is an odd number, which equals to 1 square. Going forward, 1 plus 3. Both are odd numbers. So by adding these numbers, we get 4, which is a perfect square of 2. Similarly, by adding 1 plus 3 plus 5, we get 9, which is the perfect square of 3. Similarly, if you add next odd numbers one by one, you will get a square number only. Let us check one square number, that is 16. Is this 16 a sum of successive odd numbers? For getting the answer, we will start subtracting 16 minus 1, then minus 3, then minus 5, then minus 7. Yes, we get 0 after subtracting the odd number from 16. Now, let us take another example. Say 10. Now, let's subtract 1, then 3, then 5 from it. We get 1 as remainder. Thus, from this we can say that if a natural number cannot be expressed as a sum of successive odd natural numbers, starting with 1, then it is not a perfect square. Let us now understand one another pattern of sum of consecutive natural numbers. Let us understand through an example. Here you can see 3 square is equal to 9, and 9 is expressed as the sum of 4 and 5. Going further, for 5 square is equal to 25, and 25 is expressed as sum of 12 and 13. Similarly, find for 7 square, 8 square, and so on. Therefore, we can say that square of any odd number is the sum of 2 consecutive positive integers. Now, we will learn about next pattern of square, and that is product of 2 consecutive even or odd natural numbers gives a square number minus 1. Let us understand the concept using a formula, that is a plus 1 into a minus 1 is equal to a square minus 1. Using 2 odd consecutive numbers in formula 3 and 5, we get 3 into 5 equals to 15, which is 1 less than a square number 16. We can express this as 4 minus 1 into 4 plus 1 is equal to 4 square minus 1. Here are some more patterns of a square number. Look at the image. Seeing this image, you will understand the different patterns of square numbers. We have now properly understood about the square numbers. So let us now find out the squares of numbers, say the square of 3. Yes, correct. It is 9. Square of 10? Yes, correct. It is 100. These were the squares of small number, which we can memorize, but can you find the square of 24 so quickly and easily? Your answer will be no, as we cannot memorize the squares of big numbers. So we will learn and understand how to find the squares of big numbers in an easy way. Let's find out the square of 24. You can find it by expanding 24 as 20 plus 4. So the square of 24 will be 20 plus 4 whole square. Expanding it, we get sum of 20 into 20 plus 20 into 4 plus 4 into 20 plus 4 into 4. Therefore, by calculating this, we get 20 square plus twice of 20 into 4 plus 4 square is equal to 400 plus 80 plus 80 plus 16 equals to 576. Thus, 576 is a square of 24. To remember squares of large digit with 5 at its unit place, there is an interesting pattern. Let us learn with few examples. Consider 15 square. It has 5 at its unit place and is equal to 225, which by expanding we get 1 into 2 into 100 plus 25. If you see for 25 square, it is 2 into 3 into 100 plus 25. So we can see that for finding square of a number with units place as 5, just multiply the other digits with their consecutive number and 100. Then adding 25 to it, we get its square number. Let's see some other examples for it. Let us revise all that we learned in this module, square numbers.